Hi everyone, this is Miss Rapp. Welcome to Unit 2, Lesson 3, Analyzing Functions. So make sure you are on page 58 of your notes. Awesome, let's get started. So I'm actually going to start the opener with you just so we can talk about notation. So it says, for what values of x is the function increasing? So I got a highlighter out, so I recommend you get a color. And let's just visually look at where it's increasing. So I would say it's increasing from here to here, and I would say it's increasing again at this little jump. Okay, so how I want you to write that in interval notation. So for what values of x? So from here to about here, it's increasing. So we could say that's about from 0.5, and I do a parenthesis because it's kind of switching here. So at these switches, you do a parenthesis to, let's call that 1.5, and that's another switch. It's increasing. And then it starts to decrease. So, but then we're going to union it with this piece of increasing. So I would say that's around 2.5, and then it securely ends at 3. So I put a bracket here because it's done there. At turning points or where it changes direction, you use parentheses. Okay, so now I'm going to stop, and I would like you to answer, try your best to answer B and C and D. So I said that it was decreasing from 0, because that's where it starts, because it starts at 0 to 0.5, so that's a decreasing part. And then it starts decreasing again from here to here, and I called that 1.5 to 2.5. Does the function have a maximum value? Yeah, maximum value would be at 0.5, where it starts, because that's our highest point. And then it says, does it have a minimum value? So now I'm looking at my lowest point, and I said that was about 2.5 at negative 4.5. Okay, so let's talk about what this really means. A function is increasing when their y value increases as their x value increases. And remember, at any time you can pause this to write this stuff down, and you should be writing this stuff down. So it's decreasing when the y value decreases as the x value decreases. Pretty straightforward, but definitely something to think about. Take a moment, make sure you have that written down. Okay, this lesson is pretty vocab heavy, so if you like note cards or anything like that, I recommend those. So when we're talking about maximums and minimums, we're going to use x equals blank for this. So you're referring to the height of the graph, but I want to know the x, what the x values are doing. So for example, if I asked someone when they were running their fastest, they would say, oh, at 5 seconds, I was the fastest, talking about time, which is normally your x value. So that's just an example. So the absolute maximum is the highest y value in the entire function. So absolute, out of every possible option, the highest y value. So that's what absolute means, like out of all the options. So absolute minimum would be lowest y value in the entire function. Relative maximum and relative minimum, there could be a lot of curves in your graph. So I just want to know about all of the maximums and all of the minimums. So you would list any lows or highs here. So this is a way to explain this is highest Y value in an increasing or decreasing section. And this would be the lowest Y value in an increasing or decreasing section. And we are going to talk about all of this, but first we have to make sure we have the vocab down. So there could be more than one relative or maximum minimum. So these will only have multiple. This will have one. Let's look at some graphs. When identifying increasing and decreasing intervals, we will always use interval notation. In relation to the x coordinate. So if I look at where things are increasing, and I always like to highlight, so I would say from here to here, I'm increasing, right? We're going up. And then we go down. But then from here to here, we're increasing, and then we go flat. So I can think of it as different sections. Here, I'll even use a different color. Here's where we're decreasing. And this is neither increasing nor decreasing. It's a flat line, so it's staying stagnant. So increasing, I'm looking at my green. So I would say we're increasing from, so this goes all the way down to negative infinity. So from negative infinity, so we come from negative infinity, we come up the graph, and then we hit the graph. And we stop increasing at 1, 2, 3, at negative 3. And I'm going to do a parenthesis because at negative 3, we are kind of in the middle. It's just our stopping point, right? Because at this point, we're increasing, but then from here, we go down. So parenthesis helps us there. And then I do a union because we don't start increasing again until positive 1 to 4. Okay, my decreasing segment is just right here. So I'm only decreasing from negative 3 to positive 1, right? That would be negative 3, and that would be positive 1. We're talking about the x coordinates. Once again, we will always use the x coordinate. This function has a relative maximum at, so I look to see where my highest points are. So there's a high point, and there's a high point. So I can just give one of them. So one of them would be x equals negative 3. Notice there are no y values even listed, like they're not even checked off. So there's a relative minimum at x equals 1, because that's a low point. Okay, so these are what the problems are going to look like. They have a lot of pieces, but we're going to go through every piece slowly, one at a time. Let's start over here. Is this a function? So I'm going to do my vertical line test, like we did in lesson 1. We're good to go. That's totally a function. Okay, but is it 1-to-1? Pretty clear that it's not 1-to-1 because these y values get repeated a lot. So that was a little review. So we are hitting a lot of different things right here. So I'm going to go very slow, and feel free to pause at any time. Identify the domain in interval notation. So my domain are what numbers are being used. So if we look at this, it seems like these graphs go on forever. So let's throw some arrows on there. So eventually all my x values will be used and all my y values will be used. So all real numbers. My range, because of these arrows, we're going to be going up and down forever. So all my y values will also be hit. So all real numbers. Okay, there goes domain and range. So it asks about increasing intervals. So I would say I start with highlighting. So I'm going to go green for increasing. So from here to here, we're going up. Remember, you read graphs from left to right. And then we go up again here. So all my green is my increasing. And then let's just hit my decreasing in blue. If you don't have two colors, totally fine. I just think it makes it so much easier. So increasing, I'll put a little green dot right there. So we are increasing from, let's call that negative infinity, right? Because it's coming from negative infinity. It's coming from over on the left side to, I'll call that negative 1.6. And it's at a turning point, so I'll put a parenthesis there. And then we don't start increasing again until over here, so we union. Let's call that, so that would be 1, let's call that 0.6 to positive infinity, because we just keep increasing. We'll be increasing forever there. Okay. Decreasing, we're going to use my blue pen. Like that. So we are decreasing from, we called that negative 1.6 to 0.6. Try to be consistent with the numbers. No need to re-estimate. Okay, relative maximums. So when I look at relative maximums mean between an increasing and decreasing period. So that is our relative maximum right there as an x-coordinate. So that x-coordinate is x equals negative 1.6. I think of it like tops and bottoms. So like that's a top, this would be a bottom, or a ceiling and a floor. A minimum, I see a minimum right there, and we called that x equals 0.6. Okay. Identify absolute maximums. When you have your graph with arrows going to infinity, there is no absolute maximum or absolute minimum. So we don't have to answer these questions. It's not applicable because it goes on forever. Infinity isn't a number. We can't label it. X-intercepts as points. So x-intercepts are where they cross the x-axis. So we will have 1, 2, 3 x-intercepts. So we'll call that negative 2.1 comma 0. That's 0, 0. And then this would be 1, 0. Okay, y-intercepts is where it crosses the y. Looking at my y, it only hits the y right here, which is at 0, 0. Okay, we did a lot in this lesson. I highly recommend coming back to this video and going through your notes one more time. I will see you in class. Thanks, guys.